means continue with the with all these things. Okay, then what we need to do. So yesterday also we had a meeting. So now from the last, I think it was a few days back, we had a meeting with all deans, heads, president, and all the means academic staff, teaching faculties. And now what was outcome of that meeting was that based on the means like information received from the office of the vice chancellor, so we have to complete the syllabus on time, means all the teaching learning has to be online. So those things which start online will not be repeated back when you come back to the college. Means when you are going to come back, that is also not sure. So we are asked to complete as per the schedule. Maybe by mid of May, we have to complete all the means syllabus and all the re-assessment part also. So we are asked to complete the assessment part also. So assessment can be in any form. It can be in a assignment form, or it can be a quizzes in VLE, or it can be, depends on the module tutor. So how, but I feel that maybe a short question types might be possible in BLE, but other than that, like face test and semester end exam, as of now, okay, we cannot conduct online. So all these things, this part, but we are asked to explore the ways, different ways to assist the student. But what I feel is that these two things cannot be done like means face test or semester end exam. So please be careful, that be mindful that OBC, from as per the instruction received from the OBC also, and from the last outcome of the last online meeting. So you should have a minimum of 90% attendance in online class also. So if you do not have attendance, so please inform your friend, those who are not able to join the online, those who have not joined the online classes, please ask them to attend the online classes. So if you do not have a 90% of your attendance, you are not eligible to sit for science examination, or you have to repeat this module. So this was made clear to us in last meeting, that we are asked to inform to the student that you have to take online classes. I know that I have received so many mails, from messages, email from students from different batches, means from different means years, or from different batches, that regarding the connectivity problem. I know it means this was the problem even I see it during the meeting, but as per the instruction received from the office of the vice chancellor, that you should be able to like go to the places where there is a connectivity. So that was what we are asked to inform to the students. So it's your responsibility to find out the place where there is a connectivity, and if you do not have a system, or where you can access the, means it's your students' duty to find out, to have either a smartphone or a laptop to means continue with the online classes. So that's why you are given a step in to have to means to attend the online classes. So that was what we are asked to inform to the students. So we have to complete the syllabus anyhow. I know you might face so much a problem. I know at this period of time I have received so many messages, but we are also quite helpless, because whatever we are asked to do, we have to do that. So we cannot do away with the online classes, so we have to do the online classes. Attendance should be 90%, but it depends on like, means to 90% of attendance should be there for all the modules to be eligible to. But we never know when you'll come back. I see that April, May, we may not be able to come. You may not be able to come, but if you are able to come in June, then we have to complete, do it for 1.5 months, then complete this semester. So, but we never know when you are going to come back. Maybe it might take a whole year also. So we're asked to continue with the online classes. So that's what I want to convey to you. So please ask your friends, those who are not here, tell them to come for the online classes. I'm not telling for only for power electronics, but for all the modules, you should have at least 90% of attendance. So that is what the other module tutor might have already done. So Please, those of you,
Yeah,
can you mute your microphone? I can mute from here also, but sometimes we need to talk. That's why I've given the flexibility to the students so that whenever you have a doubt, so that you can ask me. But please don't disturb in the middle of the sessions, so that there will not be means flow will be disturbed. And I know sometime I had even there was a feedback that student used to scribble on the board, right? So these things, please keep it in your mind that we are doing for you to. I know this is quite at this crucial time. It's quite difficult, and I know that when you sit in front of a computer or in a laptop, okay, for almost 2-3 hours, I know it's quite difficult, but please bear with us. So we are also equally working hard to at least try to teach you whatever is possible through online. So please keep in your mind that this we are doing for you only. So if we do not teach, then you might have to have, sit for another one semester for the same thing. So if we complete our syllabus, and if you are serious on this all these things, then we can even complete this. If you have even if you come back in June, we can complete this semester. All the practicals will be done when you come return back to the college. Practical, we cannot do anything online, but theory or whatever is there, we will have to do it. So if you have any problem or any, please share with me, so that if you have a genuine problem, or so that you share with me, so that I'll convey to the office of the DEA, so that we can discuss in the meeting or in any other forum. Okay, so if it's then I'll start my means we'll start with our course. So I'll just recapitulate whatever we have done in the last class. Okay, that we're doing the half control rectifier. So controlling a with the help of a with the help of a HCR. So we have seen this all this principle of operations, and how do you classify different type of converters, like classification are done depending on the semi converter, full converters, like dual converters, and based on whether it's one quadrant or a two quadrant or three quadrant. Okay, all four quadrant systems, or so three phase or single phase. So all this we have seen principle of operations. Okay, now we'll see that a single phase half wave converter with a resistive load. I think we have stopped here, right? So in this one, in single phase half wave converter with a resistive load, that the once this anode is positive with respect to cathode, and this is time when HCR will start means is ready to conduct. But the thing is that you have to trigger this HCR with the help of a positive gate signal. So once you give a positive gate signal, so with a positive gate signal. So once this, when you trigger this SCR, then this SCR will start conducting. So positive half, the anode is positive with respect to, so it will start conducting, and thyristor is ready to, during the negative half cycles, the thyristor will block the flow of load current. So this, during the negative half cycle, this thyristor will block the flow of the current. And now you need to know that what is a firing angle. So at what angle are you going to fire an SCR? So when you fire an SCR, okay, means is defined as the angle from the instant SCR get forward bias. So is something that when the SCR get forward bias, at that instant SCR get forward bias to the instant it is triggered. So that is a firing angle. So this is the angle. This is the angle when the SCR get forward bias and the instant when the SCR get fired. So this angle. So this angle from here, the instance where the SCR gets forward bias and the instant where SCR get fired. At this instant, this is alpha. This so this angle is instant where the SCR get forward bias at the instant, and when it get fired. So this angle is alpha. So it depends on this. Later on we'll see a graph. Okay, if this alpha keeps on increasing, then output voltage will keeps on decreasing. So that is what. So at the defined as an angle measured from the instant SCR get forward biased and the instant it is triggered. That portion is a firing angle. So at the instant of the delay angle, this is also known as a delay angle. So alpha, so V naught rises from 0 to Bm sine omega alpha. So when the instant the delay angle is alpha, V naught will rises from 0 to Bm sine. So it rises from 0 to Bm. So this is the, so Bm sine omega t. So this, it will rise till here, Bm sine alpha. So it from 0 to the maximum point, Bm sine omega t. So this will keep on rising, and at this point it will rise here, and again it will fall back to when it is pi. So V naught rises from 0 to Bm sine omega alpha. So it depends on alpha. So if alpha is 90, is sine 90 is equals to, so you know this, right? Bm equals to sine alpha. So it depends on the value of alpha. So for resistive load, I naught is in phase with V naught. So if you see here, so this is I naught, DC output current. So I naught, this is I naught is in phase with, exactly in phase with this V naught. This is the output voltage and this is output current. So these two are in phase with means I naught is in phase with V naught. So the circuit turn of time must be more than the SCR turn of time. It means that you cannot turn off the circuit. Okay, this whole circuit turn of time should be more than the turn of time of this SCR. So SCR's turn of time of this SCR should be less than the turn of time of the whole circuit. So that is what it means. It means that you cannot turn off, that means like your circuit is turned off. There is no meaning on this. If your circuit is, means if your device is still conducting, and it means like your whole circuit should turn off time should be more than the turn off time of that particular device. So that is what it means to see. So circuit turn off time must be more than the turn is specified by the manufacturers. Means that manufacturer will specify that the circuit turn off time is this much and the turn off time of the device is less than that of a whole circuit turn off time. So variation of the voltage across the thyristor as shown in the figure, thyristor remain on from omega t equals to pi alpha to pi. So this is omega t equals alpha to pi. It means that output voltage will vary from, means like it starts from alpha, this is the point alpha, and it goes up to pi. Similar to this, even the DC current output current will from alpha to pi. So during this time, so voltage across the thyristor. So when this SCR is conducting, voltage across the thyristor will be 0. So across this thyristor will be 0. But in practically, this is not equals to 0. It's between 1 to 1.5. So this is a period. This voltage across the thyristor is 0 at this point. So if you see this, there is a certain voltage rise in the voltage across the thyristor during this interval. Again, in negative half cycle, till this pi to 2 pi plus alpha, till this point means that the voltage is, certain voltage is there, negative voltage is there. So this is the voltage across this. So average the average load voltage across the load R is shown in the figure. So if we have to integrate DC output, DC voltage is 1 by 2 pi integration of alpha to pi. So you have to integrate between alpha to pi. So output DC voltage is between alpha to alpha. From this point to this is a supply, means source voltage, Vs. So it's a pure sinusoidal wave. So your source voltage should be, so if you want to find out the output voltage, then you have to integrate between alpha to pi. Alpha to pi, Bm sine omega t. If you integrate this, you will get Bm by 2 pi 1 plus. So I think this is quite simple integration. So you will get 1 plus cos alpha. So we have been doing this similar type of thing. So maximum value of DC occurs when alpha equals to 0. It means alpha is equals to, so cos 0 is equals to 1. So this is the time when you get a maximum value of VDC. So VDC max will be Bm by 2 pi into 2. So maximum value will be Bm by pi. So average load will be VDC by R. So in this case, we have pure resistive load. So if you just divide this output voltage divided by R, pure DC means a resistive load, then you will get IDC. Similarly, we can find out the VDC output VDC RMS value. So RMS value will be Bm 2 root pi. So pi minus alpha plus sine 2 pi 2 alpha by 2. So with this, this is our formula for VDC RMS. So similarly, we can find out IDC RMS. So all these simple things, okay, this there. If you really want to know how do you get this formula, so please go through the textbook. And I've deleted this textbook because there is a privacy issues, copyright issues. Okay, that we got some mail from the DITT that we should not upload. So if you want that textbook, I've deleted from the VLE. So if you want this textbook, please write to me in a personal message so that I can directly mail to you these two textbooks. One is by P.S. Bimra and other one is Rashid, I think. So this, I have these two textbooks, soft copy. If you do not have a textbook, so all these things are there in the textbook. So if you face any problem understanding these things, please refer the textbook. So even if you are not able to understand how do you get these formulas, I feel that these are the things which we have been doing, and I know you have been doing this even in analog electronics. So if you face this problem, please let me know and please contact me directly so that we can I can guide you that how do you get these formulas. So IDC RMS is VDC by R. So you will get load delivered to the resistive, means like power delivered to the resistive load will be PR will be equals to VDC into IDC RMS. So this is how you V square by R. So you get how you get the means power across the, means power delivered to the resistive load. How much power is delivered to this load? This is the load. So how much power is delivered to this load? We can find out with this with the help of this formula. So input power factor. So output is a DC. So you can find out what is the input power factor. So we can find out the input power factor similar to this. If you see this, so this is similar to this. So we can find out the input power factor. Now, variation of the average output voltage with delay angle. Now, if your delay angle is so, this is the variation when the output voltage will depend on the delay angle. As the firing angle, at the angle this angle increases, keep on increasing. Okay, then your this voltage, average output voltage will keep on decreasing. Output voltage is this is a maximum. When the delay angle is 0, then the average means output voltage is maximum. It's just given in per unit system. So as the delay angle increases, this voltage average output voltage will keep on decreasing. It keeps on decreasing. So it is keep on decreasing, and when the alpha equals to 180 pi, then it will be equals to 0. So as the firing angle increases from alpha to pi, its average voltage decreases from maximum value to minimum value. So output voltage will keep on decreasing. So it's same thing here. I can even say as this alpha keep on increasing here. So when this alpha, if this keeps on increasing here, then DC output DC voltage will this. It means that this area is this. So this, so it is keeps on increasing. If alpha keeps on increasing, then output DC output voltage will keep on decreasing. This is the same thing shown here. So if the angle delay angle alpha, so this keeps on increasing, then so this output DC voltage will decrease. So now we'll solve this problem. Did you copy this form? I think you must be having that. I have already uploaded the PPT, so you must be. We'll solve this problem now. Is it okay? Now we'll solve this. So can you note down this question first? I think it's not there in. It is not there in your PPT. I had just written this question today morning only. So can you just copy this question first? A half-wave control rectifier is supplied from 120 volt source. If load resistance is 10 ohm, find the load voltage and power delivered to the load from the following delay angle. Alpha equals to 0 and alpha equals to 45 degree. If you have a pen and a paper, then can you please copy this question?
Done, sir.
Okay. Done. Okay, wait. Okay, I'm just trying to do this screen mirroring. There's some problem. Wait, okay, there is some problem with this. I think there's some problem with the screen sharing. Okay, I'm not able to share this. So can you do this question? Half wave control rectifier is supplied from a 120 volt source. Okay, how do you show this? Can you give me 5 minutes? Okay, I think the problem is with this. No, I think I'm not able to connect. I think there is some problem with the network. Okay, I'm not able to share this means screen with my mobile. Okay, so not able to connect with the Zoom, so we'll continue with this. Okay. So half wave control rectifier is supplied from 120 volt source. Okay, if load resistance is 10 ohm, and find the load voltage and power delivered to the load for the following delay angle. So you just have to have this. Okay, VDC equals to Vm by 2 pi, so 1 plus cos alpha. So VDC is equals to Vm by 2 pi 1 plus cos alpha. So you have to change the value of, so what is Vm? The source voltage Vs is equals to 120 volt. Vs is given as 120 volt. So how do you find out a Vm? So Vm is equals to root 2 into Vs.
Yes.
So you just have to have Vs equals to 120. Can you see this whiteboard?
No, sir.
You cannot see this whiteboard.
Very
No,
far,
sir.
Now can you see this?
Yes,
Yes.
sir.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Wait, okay, I'll bring this pen, okay, so that it will be easy. I couldn't get this. I think I'll try to fix this in next class. Okay, I think it's not possible now. Okay, because of to show you in the whiteboard. Okay, from next class I'll try to fix this whiteboard. Okay, so that we'll do it in the whiteboard. Now, in this one, okay, you have to find out Vm equals to
Root
first
2
part.
times
Okay.
PS.
Can you see? Can you see here? First part is BDC is equals to Bm 2 pi 1 plus cos alpha. So Bm will be equals to root 2 into Vs. So you'll get 169.70. So from next time, okay, please sit with your calculators, pen, and paper, okay, so that we can solve the problems together. Or you want to do it yourself?
Together, sir.
You want to do
Sir.
together?
Solve together.
Hadi bir YouTube, sir.
Much better, because if you have some problem while solving the problem, okay, so that we can discuss here together. Okay. Actually, I thought of doing in a paper, okay, but I'm not able to connect this with the Zoom. Okay, we have a facility of connecting with the screen mirroring. Okay. Let me try once more. Okay, so I can. I know you all are also facing so much of problem, okay, while studying online, okay. We're also having the same problem from here also, because sometimes we need to say something, okay, and we are not able to show you, means physically writing in a paper, okay. When we show to you in the slides, then it will be difficult for you to understand also, and it will be difficult for us to convince you, because you must be like blind, okay, when you just give you the solutions, okay, sometimes it's quite difficult to even solve the problem. So anyway, okay, please try to do this problem, okay. If you face this, from next time, okay, I'll try to give you the solution for this. Okay, VM will be, can you just note down, VM will be 169 point, or
7.
you can say 170. Okay, 170 volt. VM will be 170 volt. And when alpha equals to 0, then VDC will be 54.
54.
VDC will be 54, and power delivered to the load. Power delivered to the
291.
load will be 293. 293. Then when alpha is equals to 45 degree, then VDC will be 46, and power delivered to the load will be 113. 113. Are you able to get this? 54.
Yes, sir.
170 by 2 pi, 1 plus cos 0.
Tell me, sir. 54.04. Tell me, sir.
Yes, okay. Means it's round off to 54, right? So power delivered to the load, it will be VDC square by R. It means that 54 square by 10. How much it
291. Tell me, sir.
can you know?
291.
Yeah, it must be, you might have done the round of figure, right? 54. So it is around
Yes, sir.
290, 91, 90 means that. So 293. So similarly, if you just in place of 0, if you put 45 degree, then you will get VDC is equals to 46. Then the power delivered to the load will be 213. Now, if you just imagine, it means like, just compare with this. When the alpha is equals to 0, right? VDC is 54. I just give this problem just to understand this. When alpha equals to 0, output DC voltage is 54, right? Power delivered to the load is 293. Power delivered to the load. So when the alpha increases from 0 to 45 degree, when this alpha increases from 0 to 45 degree, then your output DC voltage is only 46, and the power delivered to the load is 230. So that's what I want to convey with this problem, actually, just to make you understand this figure. So this problem is basically to find out that find the load voltage and power delivered. How much power will be delivered when you increase the alpha? So alpha is increased from 0 to 45 degree. Then the power delivered to the load is also decreased. Is it clear? Can you do this problem yourself? So if you have anything, okay. From next class, I think from next class I'll try to arrange the whiteboard if it's possible, okay, so that I'll do it in the whiteboard, and at the same time please come prepare with the calculators, pen and a paper, so that we'll do it together and try to find out the solution. Is it okay? Okay, let's continue with other problem. This is also a similar kind of problem. Okay, a single phase half wave rectifier circuit using a thyristor. So half wave using a thyristor. So you have to find out is fed by the transformer whose secondary voltage is 400 sine omega t. So find the average load voltage, RMS load voltage, average load current and RMS load current if the thyristor is fired at 30 degree. In each positive half cycle, the load resistance is purely resistive load. So can you just copy this one? So it's not there in the slide, okay? I just added these two problems today morning only. So thinking that when you solve this, I thought that I'll be able to solve by reflecting in the Zoom, okay? But I'm not able to connect with skill mirroring with it. I'm not able to, I don't know, there is some problem with the network, or last time I was able to connect, but now I don't know. Today also only 22 of you are there. So 22 means there are, I think 28 or 28, not 20, it all has to be around 26. So 4 of you are, means 4 of your friends are not there. in this case also your Vm is 400, right? And alpha is 30 degree and R is 50 ohms. 400 Vm is 400, alpha is 30 degree and R is 50 ohm. So you can find out VDC, right? So in case of alpha, you just have to put 30 degree, then load current also you can find out. So you have to find out the RMS voltage and RMS current. So if you know the formula, you can directly find out this. Here, average DC voltage is 118, 118 point. Just note down the answers. Okay. 8 volt. Then average current is 2.3. If you just divide with the R, you will get 2.376 ampere. Then RMS voltage is 197.1, 197.1. Then this volt. Then your current will be 3.942 ampere. So these are the answers for this problem. So please try to solve this problem. If you face, we'll try to solve next time together. I know this, if you know the formula, it's just a direct application of formulas. So can we start the next? Did you finish copying this question?
No, sir.
Still copying?
Yes, sir.
Anyway, I'll upload this in a VLE also. Okay, I'll try to upload this problem along with the answer. Okay, so that you can solve later on. Okay.
Okay, sir.
Single phase half wave converter with RL load. Exactly same. Whatever we have done, the input is a DC. Vs equals to Vm sin omega t. So the difference here is a load is RL. Resistive and inductive loads is there. So you know the problem that when the load is RL. So we have seen in when a converter when you use a diode also, we have seen similar type of diagram. So in this case, okay, the voltage will increase. Okay, output voltage will increase from 0 to Vm sin omega t, and it will become 0 when alpha equals to pi. The output voltage will become pi when output voltage will be 0 when it is equals to pi, but the output current will keep on rising and it will not become 0 when alpha equals to pi. It will keep on continue. It will rise to a certain point, then it will fall, but it will not become 0 when it is alpha equals to when alpha means when it is pi. So when omega means when omega t equals to alpha, then thyristor conducts when it receives the gate filing circuit. So it will start conducting when this is positive with respect to cathode. Then this thyristor is this SCR is ready to conduct. Then when you give a gate signal, then this will start conducting. So the load voltage at once becomes equals to source voltage. So load voltage will become equals to as shown in the diagram. So load voltage will be equals to source voltage. So it at when it's so this will increase to this point. So load voltage Vm sin omega t. So it will become source voltage and as shown in the waveform. But the inductance L force the load output current IDC to. So this will force load current to rise. It is this current output DC current will be rising. So it will rise rapidly. After some time, IDC reaches the maximum value. So this IDC is reaching the maximum value at this point, at certain point. Then it will fall down. Maximum value and then begin to decrease. So at omega t equals to pi, VDC is equals to 0. When omega t equals to pi, at this point, VDC is this output DC voltage will equals to 0. But IDC is not 0. If you see here, IDC is not 0 at this point. So IDC is not equals to not due to the existence of the load inductance. So because of this condition, inductive load, IDC is not 0. But after omega t equals to pi, thyristor is subjected to reverse anode voltage. So when omega t equals to pi, this thyristor will in reverse bias. But still the current will continue to flow. At this point, when omega t equals to pi, this will be reverse bias. But reverse anode voltage, but it will not turn off at some angle beta is greater than pi. So, but IDC reaches to a 0 and thyristor is turned off. So this will reaches to the 0. So this, it means that it is continuing up to this point beta. Actually, this should be supposed to be 0 somewhere here at omega t equals to pi, but it continues to flow. But this SCR is conductive, still means in a reverse bias. So reduces to 0 and thyristor is turned off as it's already reverse bias. So when it is beta, its thyristor is already reverse bias, but the current is started, means like continues to flow even beyond omega t equals to pi. So omega t equals to beta. So at this point, omega t equals to beta. This is the point with this is beta. So my omega t equals to beta. VDC is 0. So at this point, omega t equals to beta. VDC is already 0 in this case. But VDC is 0 and IDC is also 0. At this point only IDC becomes 0. But at this point only VDC is 0. IDC is not 0. But at this point, VDC is already 0 and IDC also becomes 0. So output DC voltage is also 0. So at omega t equals to 2 pi plus alpha during the positive half cycle, again another cycle during the positive half cycle, again this omega t equals 2 pi plus alpha. This is the point. Omega t is equals to 2 pi. This is pi. This is 2 pi plus alpha. So at this point, this thyristor will become forward bias. Again, in the next cycle, this thyristor will become forward bias. Thyristor is triggered again, and IDC is applied to the load, and supply current develops in the load as the load current. So that is the point. Again, the next cycle will, negative positive half cycle will continue to flow. Then alpha angle beta is excitation angle, and gamma is equals to beta minus alpha, which is a conduction angle. So beta minus alpha is gamma. So this minus alpha, this is a conduction angle. So you must be hearing some sound. Okay, this training is going on in our campus. So there is all military. Our campus is almost like it's covered with all military people. So trainings are going on. So you might be hearing some sound. So circuit turn of time will be. Now, how do you find out the circuit turn of time? Whole circuit turn of time. So we have already seen that the circuit turn of time should be greater than the device turn of time. So to find out the circuit turn of time, TC is equals to 2 pi minus beta by omega. This is the circuit turn of time. For satisfactory commutation, TC should be more than the device turn of time. Device turn of time is TQ and circuit turn of time is TC. So please always remember that TC should be greater than TQ. So how do we find out VDC, output DC voltage? So output DC voltage will be 1 by 2 pi alpha to pi plus alpha. So you might have remember alpha to pi in case of purely resistive load, but in this case alpha plus pi Bm sin omega t. So we can, this is if this is the case when alpha is equals to beta, but this if alpha is not equals to beta, this is the case when it's called alpha is equals to beta. But this is the conditions. But if alpha is not equals to beta, then VDC will be alpha. The your integral will be from alpha to beta. So this is the condition. There are two conditions. One is when alpha equals to beta, and when the alpha is not equals to beta, then the integral will be, your integration should be from alpha to beta, Bm sin omega t d omega t. So you will get cos alpha minus cos beta. So if you integrate these things, then you will get alpha. VDC will be Vm by 2 pi cos alpha minus cos beta. Now, what is the effect of the freewheeling diode in the control rectification? I think we have seen this in the last class also. So in this also, we need to have a freewheeling diode. Now, last time, okay, one of you have asked the question that, do we use a freewheeling diode in three-phase control rectifier? Three-phase rectifier. Yes, we use freewheeling diode even in a three-phase system. three-phase rectifier, but the alpha should be more than 30 degree. That is the condition. Means I was just going through that. There are certain conditions that your alpha should be more than 30 degree to use this freewheeling diode. So please try to find out why it should be in 30 degree. So there is a reason that why do we need to take alpha. It should be more than 30 degree. The firing angle should be more than 30 degree in case of a three-phase rectifier. We can use the freewheeling diode. So all these freewheeling diode are the power diode connected across the load in a reverse mode. So it's commonly described as commutating diode. It means like commutation diode means like it helps as a commutation diode also, freewheel or a bypass diode. But this diode will conduct when the SCR is not conducting. So main function is to commute or transport the load current away from the rectifier. So what is the main function? If somebody asks you what's the main function of the freewheeling diode, why do you need to use the freewheeling diode? Means its main function is to commute or transport the load current away from the rectifier when the load voltage is reversed. So when the SCR is not conducting. So this allows the thyristor regain its blocking state. So at that time that it will regain its blocking state following the voltage reversal. So this is a conditions when half wave, single phase half wave converter with RL load and the freewheeling diode. So circuit diagram is this. So this is half wave converter with freewheeling diode. You have a power diode, freewheeling power diode, and you have a thyristor. The freewheeling diode is connected at the anode, means like cathode of this SCR and on this point. So this is connected across the load. So this is when the freewheeling actions once supply voltage is reversed. So when the supply voltage during negative half cycle, so this is the equivalent circuit of this circuit, half wave converter with freewheeling diode. So when this at this period, this diode will start conducting. This is what output voltage will conduct, means will be same as that of the without a freewheeling diode. It will conduct when alpha equals to so certain firing angle. So it will go to maximum and it will fall to 0 when omega t equals to pi. But the current will be, means like it will try to separate in this point. Means that T1 will be T1 and at this point freewheeling diode will conduct. This is the point when the thyristor will conduct, and this is the point where freewheeling diode is conducting. So similarly, this is the voltage across the thyristors. Voltage across the thyristor is this point when between this 0 to alpha. So again pi to 2 pi plus alpha. So voltage means diode. This is the voltage across the freewheeling diode. So voltage means it means current across the freewheeling diode. So there will be a certain current flowing through this. At this point, the diode will be reverse bias. Freewheeling diode will be reverse bias, and at this point, the diode will conduct when this SCR is not conducting. So if you see this, when this is the point when the SCR is conducting. Similarly, VGC will be Vm by 1 plus cos alpha. So we can find out this. So I'll stop here. Okay, half control converters. Okay, converter bridge type rectifiers are there. Are half controls converter. There are two types actually: symmetrical configuration and asymmetrical configurations on this. It's quite noisy also. So I'll stop here. So can you solve these two problems? The two problems which I have given to you. Okay, let's
Okay,
take
sir.
your attendance. Okay, I'll just copy paste here. Okay. You must be thinking that for all the education schools, okay, it's not means like compulsory to mean just for the engagement purpose only, but for the REP stuff, okay, we have to means like for REP students those who are studying, means like the REP we have to take the attendance or all these things. I think one of the class, I think in Wednesday, okay, I think there is a classes between, because some of the third year students, okay, those who are taking power electronics, they are not able to join on that classes. So I'll try to see the alternative in at what time are we going to take, means we have to take that class also. So I'll try to see that timing, maybe when we are free, okay, when you are free also. So I'll inform you, and accordingly, if you agree on that particular period, then we'll shift that classes on that particular time. So based on the agreement between, if you agree with that timing, and we'll try to fix the time in other time when both the third years are also free and your class is also free. We'll try to fix that time. The problem here is what most of the faculties are sharing, that between 11 to 12 classes are, the network is quite slow, even as a host, okay, where as a host it's quite slow and they're not able to take the class. Is it true? Because I have not taken the class between 11 to 12 and between. So what
Yes,
is
sir.
your feedback on that?
Yes, sir. It is slow, so on 11 and 12.
11 to 12. Most of the
Yes, sir,
faculties
sir.
are taking 11 to 12. It's quite difficult to
Almost
teach in
all
the,
are same, no, sir. Almost
yes,
all are same, sir. Because afternoon classes also little bit this one's a network problem. Morning also
After
sometimes
lunch,
network problem.
sir. After lunch, we are
Depends,
facing
sir.
more difficulties, no, sir, in network.
after lunch.
Yes, after lunch, there is
So
too much
can
back, sir.
we, for Wednesday class, okay, can we fix it in the evening time? Is it possible? Evening means
No,
maybe,
sir.
or it's up to you, okay, because
No,
if
sir.
it's not convenient, means if it's not convenient time for you, okay, it's you useless for, it's like to fix the timing, okay, because that timing we have a, it's like there is a classes, okay, I want to take that classes. So when do you think that it will be appropriate time? Because 8 to 9, I feel that the network is much better than the other time, but we don't
Yes,
have a time.
sir.
Morning time 8 to 9 is not free, means it is not empty, means we don't have a space on that period. I think another one who has joined just now. It was only 23, 22 were there. Okay, I just want to, we need to maintain the attendance, okay. Someone has joined just now. Can you just tell me who has joined just now? Because I just need to later on, okay, if you're absent, okay, then you might be feeling bad, okay. Somebody has joined just now. It was only 23, means 22 of you are there. Somebody has just joined. I've already taken the screenshot of the attendance. I don't know, somebody. It was 23.
Situ, sir. Situ.
24. It was only 23 at that time when I took the screenshot. Now it's 24.
Situ has raised hands, sir.
Gamu, you just tell me, okay? I'll just
It was
add
me,
your
sir.
attendance. No problem. You might be having a network problem, okay? So I can understand that.
It was me, sir.
Galo,
Sechu, sir. Sechu.
change ina.
Sechu.
नहीं,
Sechu.
sir.
Situ, sir.
Sir, Chechu.
Okay, if it is Chichu, then okay, let me see. Chichu. Okay. So can you, when should we take the class? Afternoon class, problem came in is network.
Thimme, sir.
Afternoon, yeah. At
No,
what
sir.
time?
Sir, sir,
Afternoon
परशुराम की
1,
screen share be matub, sir.
afternoon, yeah.
No, sir. कोई screen share be matub, sir. We took a lot of time there, sir. Screen share baby, sir.
Even Hemel Sergey such happen bay, sir.
Happen.
It is a good day. Most of the classes, only COP is between 2:30 to 3:30 minutes, COPD.
No, sir. Evening come to sir, this.
Dele chenga sir ki machine 1 to 2 AM. Such means Saturday, first sir is having between 1 to 2 also. So I have to take a class.
Sir, jame ang trashigiri. I'm si tu mi sir. Screen share be matub, sir. Kogi.
Afternoon, yeah.
Oh, sir. Ko verbally lapsira babi, sir. Verbally lapsira babi, sir.
Means the problem we have shared in the meeting also, but it's not in our hand also. But it is already, the direction is from the Office of the Vice Chancellor that we have to take the online classes, okay, and we have to finish all the syllabus on time and even the assessment part also. Now, in terms of assessment part, in my case, okay, in power electronics, what I'm thinking is I've already given you the assignment, right? So my assessment part will be mostly the assessment, means like assignment only, and if possible, I'll just try to take one MCQ question, okay, multiple type of question, MCQ type in BLE, okay, but I'll inform you later on. So other descriptive type, I feel that it might not be important for you, okay, if I give you, and you don't have a proper textbooks also. I know you might not have even carried, some of you might not be having the textbook also, and it's quite tedious to go through the soft copy of the textbook. I know even we face the similar thing, okay, but I'll try to take as far as possible. I'll try to give the assignment, okay, and at least we'll do one MCQ type of question. Maybe in terms of like, I don't know, we have not got the proper direction for the face test. If we are asked to take the face test also, we might have